Hello. Our next speaker today is Tish. And I'm sorry, I'll just tell you a few words about him. He's a non-practicing electronics engineer and almost PhD, formerly a remote sensing and GIS developer, an embedded systems enthusiast, and he is currently building the logistics platform of the future in Africa. Today, he's here to tell us about end-to-end energy monitoring in Python. Please give him a round of applause.
Hi, it's good enough? You can hear me? Yes? Cool, thank you. I like the LEDs on, it's good. As you will see, it's lots of LEDs and lights and OLEDs in my thing. So my talk today is about energy monitoring in Python. It didn't always start in Python, but that's how it's these days. So when I built this, I was doing it in the backyard in my garage. I was actually doing it inside, then I was evicted to my garage because soldering produces fumes. And you'll see the story. I have a son who's young, so my wife said, okay, do it out there. Some asides about adventures in electronics in Australia as a cottage industry. You know, we have exported a lot of our industries overseas, but in order to build bespoke hardware outside of, say, defense, you have to really want to do it. And yeah, there are a few people around who are doing it, so I'm one of those guys. So what is this talk about? It's sort of the summary or the table of contents that you see. So the origins of this project in Arduino land, which is another great tool for writing basic code. Moving firmware to MicroPython. Moving data collection to Graphite, which is, is a data collection tool for usually used in calculating usage data, memory usage, temperature usage of your computer. You can use it to collect energy usage for your house as well. Data analysis in Keras and machine learning sort of bits. I don't profess to be a machine learning expert, but I have sort of a engineering data analysis background. And the future of this word, NILM, which is stands for non-invasive load monitoring in Python. So basically, how we would say how much the lights are consuming, how much the fridge is consuming, how much this laptop is consuming, all from measuring it at one point and then extrapolating, breaking it down. That's sort of the idea behind this word, that you measure at one point. It's not invasive. You don't measure every single thing, but you can then break it down. So like in a talk like this or in a hallway track, everyone is talking. You record it with a single microphone, then you break it up into every conversation from a single recording point. So where did this start? It started almost exactly 3 years ago. So the first PCB that I got made from Dirty PCBs has my son's birthday. That's the day I sent it off to the fab. So after coming back from the hospital, I sent a PCB to the fab. Making hardware is hard. So I was iterating through making PCBs, doing assemblies by selling off the last batch. Doing software iterations is easy. Doing hardware iterations actually costs you money, not just time. So you have to get stuff made, you have to spend time assembling them, and then it doesn't work because you got some trace wrong. You have to put a wire to ground somewhere. In 2017, Joel, one of the other guys from Adelaide, Python group, and he works at IBM, did a presentation because he was testing out my energy monitors. I was giving them out to friends. And he talked about trying to write a driver for reading the energy monitor data in Python, in MicroPython. End of 2017, I did a crowdfunding round based around the energy monitoring stuff, giving it out again, putting it out in the wild, seeing what happens. And this year, I have been doing this sort of lorry stuff, doing the startup stuff, so it has been busy. So I've done stuff on the side, porting the firmware to MicroPython, doing a 3-phase version of the energy monitoring thing, and just releasing it out on the wild so that you can see I have passed some hardware around. You can have a look at it, what it's like. So that's my version of it, releasing it in the wild. So the reason for starting this, which is another presentation, not really Python related, is there wasn't stuff out in the wild. The energy monitor you'd have wasn't open source. You would get something that was not capturing the data as best as you could. You couldn't put your own firmware on it. If you wanted to get a dev kit from the manufacturer of the ICs, it would cost you $800. So I was like, OK, I'll just make my own sort of thing. So yeah, it's like scratching the itch story. So I ended up doing this. So there's a bit of Python in there. And this sort of illustrates my workspace and how the code was written. This is my son. And he comes in, and he tries to do stuff. Out in the background is also part of the story is like my test rig. It's powered off. I make sure it's powered off whenever he goes in. It's 240 volts, right? So out there is a test lamp. So it's a test lamp with a current clamp around it, and you can put in various lamps. So it was pretty funny. I went to the Bunnings, and I was like, I want to test my energy monitors. What is the highest energy lamp you have? They're like, everyone wants to say, what are you doing? I'm like, yeah. So I have like a 116-watt lamp that I use to sort of benchmark my energy monitors. So yeah, so that's like a lamp test rig. I built a thing that you can put a clamp on and then plug it into the energy monitor and see how well it's calibrated, essentially. So this is sort of an origin story of the code. So I was making breakouts for energy monitors, ICs. And in order to get traction on it, you have to write an Arduino driver. So otherwise, people wouldn't be able to use it. Nobody wants to go and look up the data sheet, which is for the ATM90 is like, I don't know, 200 pages long, read the registers, and then write a driver for it. So if you want to get traction on people using your stuff, you write a driver in Arduino. So that's what I did. But then I was sort of hitting this wall where I was making an IoT device with a configuration page and writing, nowadays we have Django and Flask and everything for frameworks for writing web applications. It's essentially a web application. And if you're writing a web application in Arduino, it's no fun. I moved to MicroPython, and after the PyCon 2017 presentation, we sat down on the sprint days and did a copy-paste job from the Arduino. It was not very Pythonic code of taking the Arduino driver and lifting it into MicroPython, and it worked. So yeah, it was good. So that's sort of the origin story of the code that runs on the microcontroller. Another sort of meme or storyline of reality. This is my wife, my lovely, understanding wife. And when we were doing the crowdfunding round, you can get PCBs made, you can get them populated, but if you want to do enclosures, if you want to do cable assemblies, I haven't found a good place to do them cheaply, easily, without making thousands of batches. So we ended up crimping, hundreds of cables, a few hundred cables at home together. We sat around the dinner table and crimped cables. Yeah, so this is like the reality of things. You write code, but when you're doing you're at a computer, but when you're doing hardware, it's just spills all over the house. It's yeah. Moving the firmware. So this is sort of a brief of the use cases of what we wanted to do with the firmware. So there were lots of roadblocks, pitfalls, however you want to put it. Problems with getting things from one way of working that I know to another one. So Damien helped us port the ESP8266, or not port, just fix a few bugs in the ESP8266 MicroPython so that it would run with more flash, with 16 meg flash, which I had chosen to use. I found projects to use the OLED stuff in new ways. Learned a lot about compiling MicroPython. So one of the advantages of doing this in MicroPython was you could have MicroPython Unix port and write your firmware on a development laptop and then put the same code on the microcontroller. So you can have your framework, web framework with your static file, serving the data on your laptop, prototype rather than flashing every time to see if it does work or not to the microcontroller. So you can develop your firmware much more easier and then just load it up onto the thing. It's not just load it up, but you can load it up, yeah. So John helped us do the website. So use cases, we just went through those. It's just a summary. And the last point, it has ... I haven't actually quite figured it out yet. So the config side. So as I was saying, if you're trying to do a web server in a microcontroller, it's hard. So credit goes to John. He's here. He helped me put the web. I'm not a designer, so he helped me. Not a web designer. I can design electronics, but yeah, I'm not that great a visual person. So he has a great write-up here about the design process of the web interface that you use to configure the energy monitor, where you want to send the data, what are the important registers to set, Wi-Fi, and maybe also update the firmware. And when we were doing ESP86.6, we kept on running out of RAM, so we had to move the code to ESP32, which is good. And somebody wanted from Johannesburg said, "Oh, will this run on ESP32?" I was like, it runs MicroPython in ESP32, so we'll see if it runs in Arduino. So I provided the Arduino code on ESP32 after making sure it did work in MicroPython. So sort of reverse my usual workflow. And now ESP also has an IDF, so he's making it faster and stuff on the IDF side. So maybe there will be like a native energy monitor driver with fast SPI reads, which you can then layer with MicroPython on top in the future. This is how the web server boots up. So there are some interesting details there in the different modes in which the microcontroller runs. So you can see the Wi-Fi mode there. So the soft AP means it can run as an access point. You can log onto it with its SSID, get the site, configure it to drop onto your normal home network as a client, and then keep going beyond that, have your site, have your data, choose where you want to send it, and so on. And then, yeah, it's just listening on this 8081 port. Maybe we should move it to port 80. I don't really have pseudo restrictions on the micro. Yeah, there's only one user. So anyway, so you can do stuff like that. And that's the look of the site that John put together. And it's just loading up, and you can see the HTTP requests being made. And that's the initial page that comes up when you go to access the microcontroller, and it shows, yeah, you can manage network, you can log to a certain thing, configure the registers, update the firmware, and it's Vue.js with PicoWeb, which is like a Flask-like framework at the back, running on the microcontroller. This is about OLED drivers. So at LinuxConf, I was messing around with the OLED. In Arduino land, there is this great library called UAG2, which does like millions of different fonts and bakes them in. So this is like the default look that you get. So I'm experimenting with different fonts for showing stuff in MicroPython. The SPI driver. So this is like the way you talk to the energy monitor chips. And in Arduino land, you have to have pragmas to do conditional compiles and choose pins. In Python, you just choose the platform, and then it's in software rather than baked into the firmware. So you can potentially run the SPI driver with a small switch on any supported MicroPython board. The OTA, I haven't quite figured it out yet. Perhaps afterwards. So the OTA stands for over-the-air firmware upload. So OTA in MicroPython is not that important. You are not changing the MicroPython core that much. So you're not like reflashing the microcontroller. So most of the time you would be changing the Python file itself rather than changing the binary. So it's not that big a deal. It's actually why we chose to have MicroPython in this case, to make it easier to have less reflashing needs. But yeah, I haven't implemented this yet. Okay, so that's sort of bridging over from the microcontroller land to more sort of server stuff. So there are so many cloud providers these days, Azure and IBM and AWS, the big boys. And then there are other services, 5 times more, who have implemented a particular IoT architecture on top. And these are some of the, I would say, freemium ones. So you get started free, and then if you're really using it, you have to pay for it. So ThinkSpeak is where I started. It's like I'm an engineer, so I used to use MATLAB. So which I don't do anymore. But ThinkSpeak is owned by MathWorks, and they let you run MATLAB to analyze your data that you're collecting on their platform. That's like their value prop. Emon CMS is made by guys who make an open source Arduino-based energy monitor. Blink, Graphite is what I will talk about. IBM, AWS has their Greengrass and a few other IoT things. PV output is what I heard from a lot of the people who are using the energy monitor. They have their solar panels hooked out to PV output from the inverter, and then the inverter will tell you how much you're generating, but they were interested in my stuff to see how much they were actually consuming, which you can only see in the old school meter. So this is moving over from the ESP to putting the data somewhere. So I chose a 16 megabyte flash device. 16 megabyte doesn't sound much, but for storing just a few floats, it'll last you a few months. The biggest you can get on a microSD that I could support was 2 gigs. So beyond that, if you're storing data every 10 seconds, you'll run out. And so you need to put the data up somewhere on a server, on a bigger disk somewhere. So I used Blink, which was in Java. But then I said, OK, I'm doing this talk. I'll move my data to Graphite. The term TSDB means time series database, which is like it's a purpose-built database for storing this sort of data that has this inherent quality of being linked in time. So you can't just go from 0 to 200 in a second. So you're not storing the data points individually. You're storing them as relative to the previous data point. So Graphite has long been used in storing computational metrics. So it does these 2 things. It stores the time series, and it shows you the data in a graph. You can send it data in plain text. You can send it pickles. You can send different protocols it will understand. There are add-ons which can see what's most efficient over the wire. Over Wi-Fi, it's not a big deal. If you're using 3G or wherever, you have to actually pay for the data. Sending the data in a nice, compact format. There was a talk previous PyCon about this from some energy monitoring people as well. Getting Graphite up on our Windows system isn't trivial, but you can get it up in Docker. The 3 elements are there: Carbon, Whisper, and like a Django application, which shows you the web interface for it. You can get it up in Windows in Vagrant, which is what I've done on this particular machine. So the TSDBs is, so the storage, if you're just putting a data in Postgre and each data point is considered uncorrelated with the previous data point, if you're storing a lot of data points, it becomes a problem. and in a properly designed TSDB, which captures the inherent relationship of sequential data points, float can take a byte and a bit. So like a most efficient one will take less. Okay, so I'll just continue on this. It's just a screenshot of Vagrant putting up the thing. Docker, just to send the data, you just go, okay, connect using a socket, send some stuff. It's not super secure, but if it's in your internal system, that's fine. You can layer any security stuff on top and just send data into it. And yeah, you get nice graphs. So this is one of my friends who had solar, and he had the meter installed with 2 channels. You can see the solar generation is not a flat thing. It's like clouds come by and your panels just drop in and out. And on the other side, you can see his consumption, which is net. So the 0 and then negative for a while the solar is generating. And he has left the house. The time is like UTC time. So yeah. So you collect a ton of data. Now, what do you do with it? So this is the last part of this. So you have collected the data. You can choose to analyze it, or you can close the loop, do something with it, like turn stuff off, shift your load. Analysis section has this sort of lot of algorithms that you can run on it. So consider it as a picture of your energy usage. The things that you can do with a picture, you can analyze who is in it, how bright is the picture, how much you're using overall. You can do just statistical analysis. You can do the neural network stuff. You can do mixture models and pull out the bits out of it. And I'm really interested in people collecting their data and building up this sort of library of data. The Flickr, which is unfortunately not around Mono, but then many image storage things, they really have affected the convolutional neural networks and structure from motion. People went out to Venice or one of the tourist sites and took thousands of photos, and those photos could be used to reconstruct the place based on, so that's the SFM, the structure from motion applications. When you collect data, you can back analyze what the reality was like when you collected those snapshots. And you can close the loop. You can, turn stuff off. You can work out billing. You can do arguments over whether the microwave is affecting your Wi-Fi because there's one device which is Wi-Fi connected and is measuring your energy. You can see the microwave turn on, and you can see your Wi-Fi SNR at the same time, and you can win arguments about microwave affecting the Wi-Fi. So the LSTM is a quick word. I'm not a machine learning specialist. You can get a recipe. There's a notebook here. You can use it for predictive analysis. And this is the Cliffs Notes of what you get. So it drops out on the black swan cases in the big spikes, but otherwise you can get a pretty good predictive fit of when the fridge will turn on. So those little blips are the fridge going through a cycle. Load disaggregation you can do using statistical methods, SVM, also the LSTM stuff. And to do serious NILM, you need to capture the data seriously fast. This is an energy monitor from the US. We can read more about here. And they have got this part here, which samples at 2 megasamples per second. And they have their custom energy monitoring front end with a TI Linux core pushing the data out. And you need serious hardware. So this is a bunch of GPUs that we fried at work. They were being used for 3D reconstruction of cities. And you can close the loop. You can turn stuff off using a relays. And I got some visitors from Brazil who are interested in my energy monitor, and getting hardware made in Brazil is hard. So they're, again, sitting around my dinner table making hardware. And I'm closing the talk just in time. And yeah, it's just a summary of what you have. And there's a bit.ly link of the slides. I would like people to collect some data, put it up, and let us put together this picture of our energy usage. I'm happy to take questions. Yes.
Did you want to take questions
Yeah,
at
that's
the
fine.
front?
Yeah,
Okay.
no problem.
You can manage your own questions.
Yeah, I'm
though.
fine.
When the user registered with the soft AP and connected to their local LAN,
Yeah.
how did you notify them of the IP address that it had picked up?
The screen does it. You
So
can-
it stays on the...
Yeah, so I haven't actually worked out that sort of UX stuff,
Yeah.
but they have an OLED screen that the purpose of that is like the notifications that you want to send back, that I am connected to the AP now, this is my IP address, switch over to this one. So that's why I have the hardware I/O in addition to the web I/O stuff.
Yeah.
Or you could probably send a 301 from your web server to the other one.
I'm interested in the stability of the ESP32, having made the switch, given it's a 24/7 application. Have you had many issues with it? Has it been stable? Have you got a hardware watchdog in there to help manage that?
Right, so yeah, the hardware watchdog is like I did design a hardware watchdog in the previous next version, so it's like it's essentially like an NE555 you have to feed. And unless you feed it after like 5 minutes, it will reset to a reset. So that it's some of the designs, not this particular one that's going around, has that sort of watchdog thing. It does fail. It typically runs out of RAM, but that can maybe once a week. I don't actually have the metric, but yeah, that's a I think I'll take one last one.
Okay. Thanks for the talk. What's the reason, what are some reasons you picked the Atmel chip for the energy monitoring?
Right, okay. So I'll go back to like the options I had. Okay, so yeah, so in this slide you can see a few chip IDs that you can use. There are lots of different ones. So the Atmel one was there, would be answer A. Answer B would be, I was pretty used to the Atmel catalog. I was using Arduinos before, so I just picked another one from the same stable. It's a familiarity thing, and they give you free samples, so yeah. Yeah.
We do have a couple more minutes.
Okay,
Yeah.
yeah, I'm happy to take more questions. Yeah.
Oh, hi. Great talk. I was interested, you've ported it, your hardware to working on three-phase, and I gather single-phase. Have you had a go at single-wire earth return, which is used in country New South Wales?
Yeah, yeah.
And its associated brownouts, dropouts, and overruns.
Yeah, so part of the reason I was talking to like the energy supply people, and they don't have point of load monitoring of the voltage, so they only monitor the power, right? So I monitor 4 basic metrics, which is voltage, current, the power, and the power factor. So you can monitor the voltage and see if there are brownouts. So then you can actually feed that data back so that you can close the loop. So the energy supply is just supplying you, they're not monitoring what you're getting. So if you install a monitor, you can feed the data back. The other thing is just blackouts. So when they don't have monitoring at the house level to feed back and say, we lost connection to this bit of houses, so you can actually send the data back. There is LoRa and other stuff I have integrated in, which I can send the outage data back as well, to say, I have outage at this particular premises, and you don't have to make a call, that sort of stuff. So energy suppliers I've talked to, but I haven't actually done anything real. But yeah, it would be interesting for that.
Okay, thank you. We're out of time for questions, but Tish will be happy to talk if you can find him during the break. Please join me in thanking him again. Thank you.
Nice.